Well, hi everyone. My name is Gabriela Jara. I am part of Argentina Community Cluster, and I'm going to be hosting for the first time one of our IOTA Argentina Community Clusters Meetup. So, welcome everyone to this new edition. Uh, Even though this is my first time hosting, we've been doing these IOTA Argentina meetups for over 2 years now. And even though we are all locked up for this coronavirus thing, we thought that that was no excuse to stop gathering this time in virtual mode. So welcome everyone again, and I'm going to introduce the agenda for today. So in the first time, we are going to have three speakers. The first one is going to be Daniel De Michele, who he is the head of the IEN, the IOTA Evangelist Network. Will be doing a very short introduction or update of the current status of the IEN. Next, we are going to have Nicolas, wait for, for the last name, Schteinschraber, and Federico Gonzalez, who are going to talk about their project, Circular Energy Management. Their project has been featured by the IOTA Foundation as the Community Week project a few weeks ago. And last but not least, we are going to have our honorary speaker, who is from Canada, and it's going to talk about smart contracts. This speaker is Eric Hopp from the IOTA Foundation. So without further ado, last thing, you can make all your questions you can leave all your questions in the live chat, YouTube chat, and we'll be gathering all the questions and make them in the last part of every talk. So without further ado, we are going to be hearing our first speaker of the day, Daniel De Michele.
Hi, Gabby. Hi, everyone. Thanks for being here. So just give me a second so I can set up my screen. Okay, there we go. So I'm going to be briefly talking about the IOTA Evangelist Network. I am Daniel De Michele, and I am the head of the IOTA Evangelist Network. Because I did talk about the IEN some weeks ago in the IOTA, in the second VR IOTA Germany meetup. I'm not going to be over all of those slides. I just want to review what we have been doing of these last weeks. So yeah, projects and some community activity. So I just want to mention, just to get this out of the way, that we are technology evangelists. Okay, so the IOTA evangelist technology has nothing to do with religion and stuff. And we are getting some people asking us if we are some sort of religious group or something. No, in the technology context, uh, evangelists are just guys trying to build a critical mass and to spread the word about a given technology. So this is what the IOTA Evangelist Network is. We are actively discussing whether we should change the name or not, because we don't want to reflect something that may build fences between us and or our audience. So quickly, I'm gonna talk about this, what we call the IOTA. Basically, we had a lot of inactive members. As you can see on the slide, we were having 116 members, and most of those members were inactive. So one of the first things we did was to just clean up the member roll. and we went from 160 to 60 active members. These are members that actively communicated that they want to keep working on the IEN, and 40% of these 60 members are located in 22 different countries and are working on active projects and proof of concepts, okay? Obviously using the IOTA protocol. We will see some of these projects soon. So, well, these are the countries in which we have members. Last time I skipped Canada, so Terry Shane. Now I remember it. So yeah, as you can see, these are 22 countries. Mostly the IEN is located in Europe, but we do have some guys on North America and on Latin America, only in Argentina so far. But I think we will onboard people in other countries soon. Brazil should be a country in which we should have representation. And as always, Africa is like our weak point. We don't have anyone yet, but we will try to find someone from Africa. So these are some of the projects that IEN members are working on. So there you see things like B-Labs, Scali on eHealth, things being done by Daniel Trout in the Aachen University and Sensiri now, ACC Labs, Executumum, Biosphere by Terry Shane. So these are 20 projects that we can find on Google. If you guys want to Google this, you will find them. And they are like, this is what people is doing now. And that doesn't mean that the other members that are not listed here are not working on IOTA. Some of them are working on projects, but they just cannot speak about that yet because maybe it's too early. So yeah, amazing projects here. And I gotta say that some of these projects are gonna be showcased in coming meetups. We will talk about that too now, in fact. So one of the first thing I thought it was important to do was to resume community activity and meetups. Meetups allows us to show what we are doing. So for instance, today we will have Nicolas and Federico. They are not part of IEN. They do live in Argentina, and they will show the project in which they have been working, which is an amazing project. And the idea with these meetups is to show to the community what is being done on those countries, okay, using IOTA. So we already have dates. Well, the Argentina meetup is today, obviously, but we already have dates for the IOTA Madrid meetup and the North America meetup. And India meetup, Netherlands and Germany, well, we don't have dates yet, but soon I'm sure we will have. So yeah, this is another thing that I wanted to mention. We are in very close contact with the IOTA Foundation. In fact, next week we are going to have this meeting to align the pitch and to be in the same page. The IRA Foundation wants to be sure that we are on the same page, and we want to be sure as well, because we are trying to push the adoption of the IOTA protocol. So it should matter a lot that our actions are in the right way from the IOTA Foundation perspective. So we are in close touch and we chat every day with members. Okay, and finally, on the education vertical, I just wanted to let you guys know again that thanks to IoT One, who provided us with 5 IOTA courses for free, and to the IOTA Foundation that provided us with 5 IOTA certification for developers, IOTA developer certifications from the foundation itself. We just finished the courses of IoT One, and now we are ready to go for the certification. The main idea about this was to have this experience because we want to have courses of our own. we think that the IEN should offer these IOTA courses, not only for developers, but also for, I don't know, maybe business and entrepreneurs profiles. So yeah, I'm happy to say that we have already finished the IoT one course. 5 guys that are making it. Me myself, I am one of those guys, and we are getting ready now for the IOTA certification exam. So that's it. I just want to answer this last question because I'm not going to have a Q&A. I don't want to waste time. What's coming next is just amazing. So I just want to finish. So what do you need in order to become an IEN member? What do you got to do? So as I said in the Germany meetup, it is not enough if you love IOTA and you're passionate about IOTA, but you're not doing something on your real. I mean, we have a lot of people working on projects from different backgrounds. So we have developers, we have guys writing blogs, we have a lot of stuff. But what we expect from somebody that approaches us to be a member is, okay, show us what you're doing now with the IOTA protocol. How can you add value from your work? Okay, so it is not enough just to be passionate about the technology. But if you are working with the IOTA protocol from your background and you want to become a member, then just reach us, contact us, and we will see if you are a good fit for the IEN, and you probably will be. So yeah, I think that's all. Let me go back to the stream. Okay.
Okay, thank you, Carpincho. It's very interesting to hear the update about the things that are happening in the IN. So the next talk will be in charge of Nico and Federico, Nicolas and Federico, who are going to talk about circular energy management. So if you have questions, you can leave them in the Facebook, in the YouTube chat, live chat, and we'll be gathering all them and making them at the end of their talk. So let's hear them. Please, Nicolas and Federico.
Hi, everyone. Thank you for joining us today. We're excited to talk about this more of an update of the project you already know. We'll be covering a quick review of what's been done over these past years already, and then give you an update of the latest milestones and achievements. Then after that, we'll cover a few of the future vision topics and how we think not only the project, but markets and society and the way we interact with energy will work. And all right, let's get to it. First, quick reminder, last time we had a meetup in the Argentinian Community Cluster. We talked about the Perfect Brainstorm contest. I'm not going to cover the contest itself, but just that this was one of the first times we were featured by the foundation. And at that point, we knew this project was something that IOTA was not only a good fit, but it was aligned with what IOTA and the foundation wanted to achieve. Remember, we first started this project on 2017, so a lot has changed in the way not only IOTA interacted with the Tangle, MAM, and Flash channels, which were the main thing we wanted to show off on the contest. But we'll talk about that in a few minutes. So right now, Fede is gonna give a small update on the project, and then we'll follow up from there.
Okay, hi guys. So again, this is a short introduction. It basically has to do with transportation itself. So the present and the future of this urban commuting and the last mile especially, it's becoming mainstream already. But there's still a huge blocker for them, for us to see like all these kind of new vehicles being around us in the city. And that blocker is probably about autonomy. And of course, autonomy has to do with usually a central point where every element gets out, you know, and in terms of how to be operative, it's like really a big pain point. So in order for this, we have like several like business models that are not working because of this reason. And one of them is the share scooters that we see a lot. We see that they've been expanding in South America and then they were retracting. So why is this happening, man? And one of the biggest pain points that we saw in the cities where they were already mainstream is that people treat them like garbage. I mean, when we talk about these dockless scooters, a lot of good things came from it, like convenience. Specifically, you can use pick them up everywhere, and then you can dump them everywhere. But of course, with that convenience comes a certain responsibility that people, of course, perhaps they have in a big scale. But with one of them making like something like putting one of these scooters in the entrance of a house where one person can get in or out and I don't know, crash with it and whatever, and have an accident. There comes a lot of about who's the responsibility of that. Is it for bird or life, or is it the guy who dumped it there? And because of that kind of situations, they have a really big problems for scaling. This could be just one of them, but the big one is about the autonomy. And when we talk, they have like people who picks up these scooters every places where they're dumped. And in the night, they pick them up with a van or whatever. They call themselves chargers. They bring them to their houses, they charge it, and then they have to return them into their initial position. So that's quite a rustic system for scaling. Actually, if we would like to see that in the actual COVID context, that would be like exposing these people to the virus itself. You know, picking up things that are being used by hundreds of people, or I don't know, many people at the same time. Then they have to bring it to their houses, they have to charge it, and then they have to pick it up and go outside. So again, it's really rustic for such an innovative concept and even technology. This is a little bit about the description of what I was talking about. But what if, and this is how we started initially, we had like a big plan in our heads, but we wanted to create a tactic deployment, something easy to start. And this was a great example in terms of a business opportunity and how we could provide a better service to an underserved product, right? So what if we could create like these charging stations with the purpose of not just fully charge your battery, but just to give out small power charge that would be the necessary to give enough power so you can complete like the 90% of the travels that we mapped, that is about like 2 kilometers, 3 kilometers. Usually it's like a 15 minutes ride. And we were thinking about, okay, so if we can have like this battery that could fill an X amount of vehicles, so why wouldn't they just simply charge them in these micro moments so they have a free whether they are, I don't know, waiting for a coffee or waiting for the train, or even stopping by a place and just plug in, answer a couple of messages or whatever they should, I mean, go up. And one of the important things is that we were planning that this could work out in case of necessary, right? So it's like, okay, so you're like getting out of shoes, you need energy like really fast because you know that you won't get to your house. So where can you stop by, you know, which is the nearest station? And what if these actually stations could be like a standalone solution? So they wouldn't have to be connected to the grid, even though they could. But they could also be fitted by other kinds of energy, right? So solar panels and other kinds of energy. So this could be like really interesting because you could get to places where the energy grid is not that common, right? Like super suburban areas. Or you could use it in places where the grid is common, but where you want to use, again, renewable energy sources. And that's not just everything, but what if these like energy stations could balance the charging stations, you know, could balance the price of this, let's call them watts. What if according to the demand, they could have like dynamic prices, as probably it works in many of other places with the regular grid. And that wouldn't be everything. What we're talking about this is about decentralizing the energy consumption, but also the generation. So what if you could sell also your energy to this? And what we're talking about is about how to atomize the industry, and how you could, for instance, I don't know, let's suppose that you have your own, I don't know, solar cell at your house and you're filling the battery. But what if you have a surplus of battery and you want to sell it to the closest station? Why wouldn't you be able to do that? And on the other side, it would be great to create this prosumer economy, and that is when the really decentralization of this has the true power and has the possibility to grow. This is like a technical project overview about what we were talking about, but it's really more about what I was telling you right now. And some of this information actually has like, I don't know, info and insights that we took from, for instance, I don't know, analyzing the information of the shared bicycles, which is like open data sets. And we took a lot of insights from there. And actually, we had a meeting also with the government to try to impulse this. And it was a pretty good, actually, meeting. But again, we need like a ton, hundreds, thousands of permissions and bureaucracy in order to start like a trial really in the streets. But we can start privately. So I don't know, for this, I want to switch maybe to Nico, who wants to explain more like a technical description.
Okay, so so following up on what Fede was saying, we'll be focusing on the charging stations, but just as a use case or an application of the big picture that we covered. We'll cover just right at the end of this presentation. So I'm gonna go over the process really quick because this has been the same since the start of this project, and I'll cover this real quick. If you want to know more about this, you can check out our previous presentation, which covers this process in detail. So overall, there will be some IOTA use cases that will cover along the presentation. So for now, I'll just say that the stations will charge the scooters as soon as you get to them. That will connect to the charging port and start the charging process. And a lot's gonna be going on behind the scenes. The scooter will be able to interact with the charging station, letting it know how much energy it wants to consume, at what price it's not only able to pay for, but wanting to pay for. You can integrate the bidding system at this point, and everything will be done by what it's not called MAM anymore, but streams. So now that we'll be updating all the glossary and everything from the old presentation that we gave a few years back now to the up-to-date IOTA terminology. So going straight to the control box, the main controller of the station, which we can see here on the diagram, it will not only monitor everything that's going on inside the charging station, but this is the same control box that you can use on a house, on a open space like a park, or even the lights on the street. Each element that you want to connect to the grid can have one of these control boxes. So again, the charging network of charging station network of this project is just one implementation of the control box, which, as you can see, can check the battery life, can not only arbitrage between the grid or any renewable source it's connected to, like solar panels, or even two different sources of energy, and then track energy consumption, energy generation, and also energy wasted, which can be a surplus of energy generation that's not being used or stored on the internal battery. And then it will give us status reports, maintenance notifications, and any system alert that we see fit on the different use cases. So at this point, the battery life and the time of charge will depend on the use case. So it's really useful for this control box to be open in terms of design and technical implementation. So anyone could be able to use one of these control boxes on any of their projects, any of their products. So eventually this charging network can be expanded as anyone wants to integrate with it. And as I was saying, the control box could be act as the connected meter, as currently some countries have been using this for a couple of years now, when they get the meter to send the energy company back all the energy consumption, and even if they get a surplus of energy, they can sell it back to the grid. But there's this contract between the consumer and the company that's not open. The company manages the fees, and they charge a lot of fees on top of whatever you sell back to the grid, and they cannot have a say in that. So using the same concept on a smaller grid, or a microgrid as we call it, will help the flow of energy to go from stations that are connected to the network, but also connect this grid to the main grid. Here I have a bigger diagram of the control box, but as you can see, there's this charging network that's connected to the control box, which already has two mains of energy sources. One is the main grid, and the other one is a battery connected to a solar panel. So it will start going back and forth between these two sources, depending on what's best at the moment. So going back to IOTA, this is one of the first reasons we started working to implement IOTA with this proof of concept back in 2017. At that point, we had MAM or MAM as the means of communication between the station and the scooter and our information exchange platform. So everything was done via authenticated messages, and only those who were supposed to get that information were able to see the actual info. And then at each point in time where the connection of the scooter and the charging network was supposed to happen. Then that was covered by MAM. Now, if we want to talk about how the payment was performed, we moved to flash channels. And if you want to know more about that, there's already one presentation about flash channels on this same channel. You can go and watch that later if you get any interest in that. Note that the flash channels changed a lot in a couple months, so there's going to be more likely another presentation on the updates of IOTA flash channels. So the main use of the flash channels on this prototype was to perform a stream of energy and not a full charge. And then once the full charge is finished, you would pay for whatever you were consumed by the scooter. So as the energy is flowing from the charger to the battery, the scooter is paying for the stream of energy as a stream of small payments and microtransactions that at any point in time will allow the scooter to be happy and not trying to steal energy from the station, but at the same time, the energy station will be able to give out energy knowing that it will get paid for it, and there's no way the scooter will run away without paying for the full charge. But again, this is all covered on our last presentation. Here's a small diagram that will go real fast. And going back to the prototype, Fede, you can continue.
Sure. So basically, we had this hypothesis. So we needed to test it. So we needed to create something with whatever we had, something that we can work, right? Something that we can see, we can explore. So we successfully filled a 14 pairs battery in the day using a small, like 50-watt solar panel. And that, according to our calculation, should be enough to provide like 15 minutes power charge to about 10 to 11 scooters to get this extra autonomy. You know, it's like the yellow tank. And again, the next slides are a little bit about the images of this, and I can give you back the control of this. Nico, if you want to explain further details about the hardware.
Yeah, so here's the original prototype elements that we used. The number one is the control box. And as you can see, it has two AC ports that output, in our case, 220 volts, but it's obviously regulated for 110 if you're on that region of the world. And then what you can see here is that the whole thing will get energy from the solar panels to the battery via the controller that charges the battery, and then from the battery through the inverter, that's number 3 on the diagram, will turn the 12 volts from the battery straight to 220, so we can plug in anything we wanted to. And this was our first prototype that got us really excited to see that we could store 11 charges worth of energy and get this really easy to scale and replicate. And then we started testing and testing and testing, and we figured that every part of this prototype was almost off the shelf. There are just some of the elements that were needed to be programmed, and that all that code was really easy to put up together. And we were really, really excited to see that this was something that anyone could replicate. And giving on to more tests, we started giving the user interaction more importance. And stopped worrying about the hardware, which we knew we could make work. And as you can see on the left here, there's this screen on the control box that used to tell the user what step or what phase of the charging process they were. So we started working on going out and take the solar panel out to the street and start testing on the real scenarios. But then we got a block from the city and the government. They told us we needed some permissions, and if we wanted to get this out on the parks or green spaces or open places from the city, we were supposed to get the certification that they weren't ready to give out yet. So what we did was start concepting.
I can jump on this one.
Yep.
So again, yeah, what we wanted to do was like design something, keeping in mind the different kind of users. So the first one was like a standalone structure, right? Something that you could place like anywhere. It didn't need even a grid, right? It was like I don't know, like an ATM portable. So you can put it anywhere. You can pick it up and then take it to another place and then take it to another city or whatever. So it was the thing with this, what we were trying to do is not to compromise too much space. Should be like a standalone structure. This was just for you, for 2 scooters. And the solar panels should be on top of this. It will work with, I believe that it was like 2 solar panels, about the same size that we showed you the pictures before this. And it would have like, again, an internal battery wall with all the information should be like stored, all the batteries. And then just a touch screen, you know, for every kind of user interaction. And an outlet, of course, just to plug whatever you want to plug, because if you wanted to bring your own battery, you should plug it anyway. And we started working also with this battery swap concept that could be also very interesting in order to make it fast, right? So you could change it and switch just batteries and not have to wait there till you plug it. And then we have the other one. Okay, so I'm just looking at the new ones. Yeah, that one. Then there was a second concept which was more like city, more like urban, right? So you could just plug a lot of different vehicles at the same time. And again, these are 2 different concepts. One is more urban, and this one could switch between the grid energy and the solar panel, and could switch according to the convenience. And as Nico was saying, when we had this meeting with the micromobility guys from the government, they said, "Oh, this is awesome. Yeah, but in order to test this, you need 100 different permissions, a lot of stuff." But they say you can definitely start with some kind of trial in private spaces. So we thought, okay, so what kind of private spaces? And we thought about, okay, maybe like parking lots, shopping malls, cafes that have their spaces to dock the bikes. We could use this kind of stuff as well. So we needed to change into something like smaller, you know, to try our hypothesis in real use. And that's where we can jump to the next one. These are like the new models. If you want, you can change. Yeah. So basically, these are the new renders of what we were working on, which is a pretty smaller structure, much portable, and that you can use like almost anywhere. And you can plug in the grid, or you can connect it to the power cells, to the solar cells. It was originally thought to have both plugs for the 2 most common kind of scooters, which are the Xiaomi and the 9-watt one. So with those 2 plugs, we were able to basically connect 90% of the market share between what are like e-scooters market at least. We had a small LED screen there, and and again, the funny thing with it, or the interesting thing with it, is like it's really small, it's portable, you can test it in like any kind of private place. And that was what we were looking for with this, like try to test it. And I don't know, Nico, if you want to add like anything on this.
So I think you covered it really well. So right now we are playing with the idea of two different ways of charging. One would be the traditional way of charging a scooter, which is plugging the charger to the charging port of your scooter, waiting there for the most time you get to charge. If you have just 5 minutes, you will only be able to charge those 5 minutes. But eventually, we thought of a way of taking advantage of the removable batteries of some of the already mainstream scooters, which you might have seen. They have these green batteries on the handlebar, or some of them have them below the base of the main platform of the scooter. And as Federico covered these a few slides back, these green batteries can be removed, used, and then replaced with uncharged ones or empty ones. And then you would only need to get to the charging station, take one of the fully charged batteries, replace it with the one that's empty on your scooter, and then be right away with the fully charged battery. And then this will allow you to stop just for a minute, change your battery, and be on your way without being stopping for 10 or 15 minutes, which might be useful, but at some points not as convenient as you might want. So this is one of the other business models that these charging stations can have. We've covered a few already. One would be a subscription for battery swapping throughout the charging station network, or you can bring your own battery and just plug it there, wait for it to charge, and then take it away with you. And this opens a lot of space for not only charging stations for scooters, but any thing that you can use a battery for, which has this standard way of plugging, and also standard specification for you to implement or integrate on your designs or on your projects, which will allow you to make use of this charging station network. And if we see more of these stations together, they are small enough to fit on the outside of bars or maybe parking lots, and eventually we could see these shopping malls or anywhere you would normally see a pile of scooters or bicycles or even electric motorbikes outside of big venues. So while you are enjoying your movie, you're drinking a beer, or you're doing anything else than worrying about the battery, you can leave your scooter. At this point, only we're talking about scooters, but this could be anything that you want to get charged pretty much the same way. I'm sure at least some of you have seen the lockers for charging mobile phones. Well, this is pretty much the same thing. There's a locking mechanism that will lock your scooter, so there you have that extra peace of mind that no one's going to take it while it's charging. And
I want to say something about this. Sorry, Nico.
Yep.
Just what is interesting about this is that we're basically working with the example of these scooters, but what is really could be like game changing here is about what if these stations, right? What we are doing here is just chargers. Chargers are, I don't know, the city is full of small chargers. But the cool thing about it could be in the near future where probably a lot of the urban areas will be filled with, I don't know, cleaning robots, a lot of automated last mile vehicles, maybe for dropping boxes or even delivery. Eventually, this is going to happen, and probably the actual context is going to accelerate all that process. Perhaps there won't be drones, perhaps there will be motorized vehicles, malls, or whatever. But the fact that they could be decentralized, not all just live on the same platform at the same time. So they would need, I don't know, an autonomy to get to a specific point, then get back to the station, etc. If you could like atomize all this and become nodes, that could be like something like way different than what we're used to right now, where everyone is basically starting to aggregate everything in the same spot, right? And try to manage all the logistics from one space. If we could manage, this could be like incredibly for logistic business. An opportunity could consume a lot of, less hours, less effort, much slower. The things could be like way different. And again, this is a very specific example, but it could be implemented in hundreds of other industries. And that comes to our future vision, which I think is the next one. The next one. And that's something that Nico has been talking about before, but where we were talking that this is a very tactic example or an implementation of a much bigger picture. It has more to do with this, with how about storage and distribution is managed. And of course, specifically of energy, and why can't be a more democratic access to clean energy. So when we were thinking about this, it's not just to open the access and make it more accessible to anyone. And of course, when we're talking about this, it's about clean energy, but it's about what if you don't have to choose who to buy? What if you could automate that process, and the house could basically decide from who it will get the energy from, whether it's from the grid or whether it's from a house next to you that has been on vacation, so their solar powers are basically generating energy, their battery is full, and it's basically wasting energy. Why wouldn't they be able to sell it, to bid it out to the best position, to sell it, to give it away, whatever? I mean, that's what we're talking about, this circular economy. It's about trying not to waste anything, trying to get the more that we can from any kind of interaction, and trying to make it like as decentralized and as open as possible. So of course that for this you would need a lot of technical things such as a microgrid, a lot of things that Nico probably would explain right now. But when we're talking about the bigger picture, it's about a more ethic economy, especially a machine economy where, I don't know, human, not just errors, but arrogance and a lot of other things that are, of course, within us as people shouldn't be involved. And it could be like much more open with like super simple and crystal clear rules. So, that kind of market would be something like really interesting to see.
So going over what Fede was saying more from a technical point of view, here you can see a diagram of a really small city that has three main parts. On the lower right, you can see a park or an open green space where there's lights and a fountain. Though the fountain is not connected, it should. So the control box on the lower right that has these solar panel and battery for its own consumption. At night, it might need some energy from the grid to be able to light up the space. And at that point, there's also a house on the top right corner has its own main of energy generation, but also it's connected to the main grid. And you can see the difference between the blue lines that connect these microgrid or charging box networks that's running in parallel of the main grid in the dotted gray lines that are the connecting the center top lights of the street lights and all the luminaires that are connected to the main grid. So if you were to connect one charging station on the top left of this diagram, you would be able to do so the same way you would connect any other element of this diagram, like the house or like the park lights. So at this point, anything could be connected to these control boxes. So here is more evident than ever before how this charging station is just an application or a specific use case of this circular energy management project or platform, or just main concept of the whole presentation. And I think we are ready for questions in the chat. Before we get to that, we'll just ask for anyone that's interested on this project to go into the ecosystem page of this project on the IOTA ecosystem platform, and just give us a like there. It will help us a lot for getting more people to know about the project, and I feel like it's an easy thing to do, and it will help us a lot. And if you want to get into that, there's this short link on the on screen. There's a QR code too if you're more inclined to do that. But more than that, it will be great for you to give us your feedback. What's currently going on your city, or what do you think is going to be the following steps for companies on share scooters, or whatever you think your government is inclined to do, if they are on track on implementing circular energy projects or laws. It will give us a lot of insight. So if this is like a two-way street, we want you to help us build the stations. So it will be great if you can give your feedback to us. And one way would be to connect through this ecosystem page that's linked. Also, there will be a link in the description after this talk is finished. So Gabi, if you want to go ahead with some questions.
Okay, guys, thank you for the amazing talk. We've learned a lot of your project, and let's move to the questions. Okay. Okay, the first one is from Matthias. It says, how are the payments are going to work? You will need IOTA to pay for the use?
All right, that's a great question, because when you start thinking of how to get this idea to the real life, most likely you don't have a IOTA wallet with you all the time, which you're thinking of using for paying to charge your scooter. It's like too messy and too complex to get around your head right now. But eventually, IOTA won't be used as a payment method the way you would buy a drink at a bar. It will be used under this transparent way of working, which you won't be really seeing. And with this, I think you will be really good at watching the previous presentation about flash channels. That's the way these payments gonna work. But in layman terms, it will be a conversation between the scooter and an associated wallet of the scooter, or you could be the owner of this wallet and then interact with the station, which will have another wallet, and the payment will go both ways. But again, there's different ways of doing this. One is the one that I've just told you, that the other one would be just to use IOTA as a token for distributing the energy as a stream of energy while you're streaming payments, which are small microtransactions that go one after the other at the same rate the energy is flowing from the charging station to your battery. And then you would buy IOTAs at the same time you are paying for the energy. So you would use any fiat money, or like dollars or Argentinian pesos or wherever you got on your own application, which you will use to interact with the stations. And then behind the scenes, that fiat is going to be traded at some specific rate for IOTAs, and at the same time we'll use to pay for the charging process. And on the other side, the charging station can choose to either keep IOTAs or trade that back to a different currency. But this is just one way of thinking it. I think this one's the easiest to understand. But I would say you are not gonna know if you are using IOTA to pay for the charging station in the near future. Most likely, Eric's gonna be able to give some insights on how we could make all the payment process inside of a smart contract, and that way we could take advantage of a lot of functions and features of the Tangle, not only for payment but also for the tracking itself of the charging process.
Okay, great. Let's go to the next one. Could this project use IOTA smart contracts? If so, how? I think you just...
Yeah, but it will be kind of dumb for be the one to answer this question. I think this won't be a great icebreaker for Eric on his talk. So I will let him answer this one. But as a teaser, yes, IOTA smart contracts are a great fit for these certain this type of interactions between payments and energy transmission. So I think, yeah, it could be used, and you will know how in a few minutes' time.
Okay. The next one. What is missing in order to have this project working in Buenos Aires? I don't know if Federico...
Sorry.
Okay. Okay, maybe a minute.
Oh, well, he's recovering. Are you ready now? Almost. So while he's recovering, I'll follow up on this one.
I'm good. Sorry.
All right. Great.
My throat
Please don't lie to me right now. Like, we'll need to get this out of the street.
I
So,
think you need to drink a little bit of water.
so no, it's cool. I mean, basically, what we need right now is build this and start. Oh shit! I can't talk. Sorry.
Okay, Nico, can you answer this?
Yeah. So in terms of what Buenos Aires needs in terms of laws, this is more complex than it seems. For anyone to put anything on the street that's not from inside the private property, you need different permissions, and getting those permissions require that you can state that it's not harmful for the environment, it's not harmful for any citizen, and you are, if you are getting any profit of it, you need to pay taxes on that, which all makes sense. But the process of getting these permits is really, really long. And even if we wanted to start piloting, there's no way to make a small pilot without getting the government and city government, at least in Buenos Aires, involved. And they normally take these projects in, and they have these board sessions. But I think Fede can give you more info on that.
I can talk a little bit right now. So basically the thing is, there's no regulation currently for this kind of things. There are some regulations about the EV charging, but even in that point, they are still really green. They're not crystal clear right now. That's why you don't see them on the streets. On the other side, there is like some kind of policy, I believe, in this government and many others, which is about, I don't know if you know that the thing about how to raise tomatoes, that is like you first let them grow, like savage, and once they start to pop up, you use like a tutor, then you tie them, and then you make them grow, and you help them to align, etc. So there are a lot of things like happen with fintech and a lot of others industry, which they first try to make this ecosystem like start growing, right? And once there are a couple of units, start popping up and show it, then they are working on the regulations for that. But with this thing, it's kind of tough because there are a lot of interest in the middle, like oil companies and government. And on the other side, you have, again, like all the safety functionality that this should provide. In that case, what we can do and what we're working on is starting about working this privately, so you can perhaps use them into, I don't know, another charging stations, like fuel charging stations, or using them in parking lots, using them in as many private places as possible. And you can you have like an imaginary front line around the space around your building, which the street is part of your, let's say, not property, but you have, like, for instance, you can put, like, I don't know, if you have a restaurant, you can use chairs and you can use the table there in that specific line. So I believe that in those cases, you could also plant these chargers on the street as well.
Mm-hmm. Okay, great answer.
That's pretty much it.
So that was the last question.
So
Someone there
I've checked the live comments, and there's a comment saying that the link isn't working. So just try and do that in caps, all big letters. I'll copy the link on the description so you can click on it. But just the circular dash economy, just use caps, since Catley is case sensitive for some reason. So yeah, that should get the link to work. Thanks for noting that, by the way.
Anyways, they can get into the IOTA ecosystem page and search for you there. That's right?
Yes. The name of the project is Circular Energy Management, and you can find it on the ecosystem page.
Okay, guys, thank you very much. Amazing talk and great answers to the questions. So now we are going to prepare to our next speaker. Let's hear about smart contracts, and prepare to listen to Eric. Eric, hi, how are you? Welcome.
Hello. Hope you guys can hear me.
It's a pleasure for us to. Yes, perfectly.
Okay.
So, I leave you.
So, thank you for having me again. Last time I explained about the state of Cubic and how we kind of finished it off with the proof of concept for the hardware. In the meantime, I'm sure everybody has followed it and found out that we stopped Cubic as a project for now. It's put on ice, and we'll see if we can revive it in the future. But we have decided to focus our efforts on the software side first and get smart contracts as fast as possible. So this is what I'm here to talk about, and well, there have been a lot of interesting and exciting developments in the meantime. So let's just dive in. I'm going to do a brief history of what smart contracts is all about. Then I'm going to talk about why IOTA smart contracts is a level 2 protocol. I'll explain what that is when we get there. I'm going to talk about the base protocol extensions that are needed to be able to have a level 2 protocol. And then I'm going to dive into the smart contract protocol itself. And then hopefully we'll have time for questions. So let's quickly grab my notes so I can follow along. Yeah, what is a smart contract? You want to know what you're talking about, right? The first mention of smart contract was in 1997 by a guy named Nick Szabo, and he defined a smart contract as computer code that can be activated automatically when certain conditions are met. Exactly how that happened is more unclear. That time you would have servers and such. But then in 2015, we got to a point where we had blockchains, and most notably the Ethereum blockchain implemented smart contracts. And that was kind of a game changer in that field. It meant that you could secure the smart contracts on the blockchain, and it meant that everybody could see what was happening to the smart contract. And that's a very important thing to do. One of the most basic things that a smart contract needs to do is to have an audit trail that anybody can see so that they can verify that the execution of the smart contract was exactly according to the smart contract's computer code. So Ethereum was kind of the first one, and after that, a number of blockchain implementations, a number of different tokens decided to also get involved. And there are several smart contracts, but Ethereum is by far the most popular. Actually, Ethereum smart contracts is what kind of created the crypto boom, because then it became easy through a smart contract, the ERC20 contract, to create your own tokens, and that's when crypto really took off. So when we looked at that, what happened there, we already found out that blockchains have limitations, but when you look at the whole thing about blockchain smart contracts, there are even more limitations. So that's why at that time, Sergey Vancheglo, CFB, Come From Beyond, decided that we needed some smart contract feature on IOTA. IOTA was already designed to solve some of the limitations of blockchain, and this one was yet another problem that he tried to solve. So that's when we started the Cubic project. The Cubic project was a bit very ambitious. It not only wanted to create a level 2 smart contract layer, but also the underlying hardware that could support that. And well, quite frankly, we tackled a really big project with limited people, so we didn't get all the way where we wanted to be. And like I said, we decided to ice the Cubic part, especially the hardware part for now. And all the things we learned while trying to develop the messaging layer that actually works on the Tangle for the smart contracts, we took that, and last year Evangelist is my colleague originally in the Cubic team, but now we're officially the smart contract team. Evangelist started re-examining a lot of assumptions that we made in the 2018-2019 years, and started iterating through new ideas, and we came to a completely new understanding of how to do it well on IOTA. And then when the Cubic project was halted, we officially focused on the smart contract side of things, and that turned into IOTA smart contracts, as we are going to discuss today. So, the case for a level 2 protocol. First, what is a level 1 and a level 2 protocol? Level 1 protocol gives you access immediately at the lowest level of the protocol to all kinds of things that you need to execute. A level 2 protocol runs on top of the level 1 protocol, and is actually, you could see it as a separate application that uses the things that the level 1 protocol offers and adds a lot of stuff to that to implement something. It's like you have TCP/IP, and that is a layered system. IP is the internet protocol, and TCP runs on top of IP. Or now I need to be sure that I'm not confusing the order. But anyway, there are several layers. It's not important right now. There are several layers, and we are going for a level 2 protocol because we think it is much more flexible that way. So, having said that, the level 1 protocol, which is essentially what Ethereum does, it allows you to move tokens directly. You don't need signatures or anything, because every node runs the protocol. Everybody knows exactly what's going on, and the trust and consensus mechanism of the underlying level 1 protocol can be leveraged. And yeah, you just run code, you move tokens if necessary, and you get results. But level 1 protocol has a number of drawbacks, and I've listed the ones here. For one, every node needs a copy of all the smart contract code out there. Otherwise, they won't be able to run the code. That means that if you get a lot of smart contracts, everybody needs to have a copy of that. And then every smart contract that is being run has a state. And that means that every node needs to keep track of the state of each smart contract. So that is, that is a lot of data to keep track of. Then there's the fact that every node runs the code. That is a lot of processing capability that is being used to execute what is essentially very often a very simple program. So it's a lot of overkill, but well, the fact that every node runs it guarantees the trust and security, but you get to pay for that by the fact that every time you add a node to the network, that node also needs to have a copy of the code, a copy of the state, and run the code. And so there's no upper limit to the amount of resources necessary to run a smart contract. That is, in turn, a scalability issue. You can imagine that that runs out of control. If your network becomes really big, then you have a ridiculous amount of smart contracts, and no node will be able to keep track of every one of them anymore. Another thing is that what we've seen, for example, on Ethereum with CryptoKitties, is that at some point a single smart contract can, due to its popular use, get the network to its knees, because everybody is running that contract, and so all the nodes need to run all the requests for that single contract. And it's it's literally an attack factor, right? So yeah, we have rising minimum requirements constantly with every node. And not only that, but it also precludes less capable devices. If we want to focus on the IoT side of things, then you have devices that are smaller and less capable. And yeah, a node like that will not be able to run all the smart contracts, keep track of all the states, and it's simply too much. Then finally, there is not a real incentive for a node to run it, and the only incentive therefore will be to provide a smart contract with fees. That has to do with the way blockchain works. To be able to be included in a block of the blockchain, you need to be selected by the nodes, and the nodes need an incentive to include you. So if you really want to run, you need to provide enough fees. If the fees are going up, then you are having to pay more to be included in the network. We've seen this with Bitcoin, where at some point at its heyday of popularity, you would pay $100 in fees just to get your transaction processed. And it becomes completely out of control. For a lot of use cases, it's completely illogical to pay that amount of money, and therefore we needed a better way. So the better way is to do it as a level 2 protocol. Level 2 protocol means that you have a limited amount of smart contract code and a limited amount of smart contract state that everybody needs to keep track of. And that is because we have a dedicated group of nodes that run a smart contract. A single smart contract is run by a very specific dedicated group of nodes. There can be overlap between smart contracts, so nodes can run multiple smart contracts, but they don't necessarily all have to run the same one. And it means that the nodes only need to keep track of those of the code and the state of the contracts that they will be running. All the other ones, they are completely not interested. This is a much more natural way of thinking about things, because if you have only a limited smart contract that is being used by a limited amount of people, most people are not interested in what's happening with that smart contract. I mean, if I'm running a smart contract for my company, which is based in the US, then China is not interested at all in what that company in the US is doing with its smart contract. So all that code and state and whatnot, it's not important. What's important is the fact that it is still auditable, so it's logged on the Tangle, and if you want to, you can verify the results, but you don't need to run it yourself. It's not necessary for every single node out there to run it anymore. That means that it's much easier to scale, because you define your group of nodes and that's it. So if you scale up the network, you still only have those few nodes that are running a smart contract that will be running that particular smart contract. That's the predefined minimum requirements, because then you can look at the smart contract, what it needs to do, what it needs to store, etc. And that in turn defines how much processing is needed and how much resources are needed. That in turn allows less capable devices to participate in the smaller contracts. It allows for micro contracts because you can have very different incentives. You no longer need fees. IOTA is feeless anyway, but the incentive to run can be something different than fees. For example, just the fact that you need an audit trail could be enough to function as an incentive. So the registration of the processing results is an incentive. let's see, what else do we have? Well, if you run a specific committee for a smart contract, then it's very natural for the members of that committee to already have a kind of incentive to run it. For example, if you have a consortium that needs to keep an eye on what each of them are doing through a smart contract, then that is an incentive to run that smart contract and be part of it. So every consortium member will run a node, and those nodes together will form the committee that governs the smart contract. And no rewards are needed, right? It's still possible. That's why we call it a reward instead of a fee. It is not something that is fixed either. You can define it once, and that's all that's necessary. And you can then either you can use it with a fee and reap the rewards of processing it, or you can have the other incentives, and then you simply go like, okay, 0 fees, and it's completely free because the IOTA Tangle itself is also free. So that removes a lot of barriers right there. Then we have the fact that it's much more flexible that way, right? I just noted about the feeless smart contracts that you can have. Fees are no longer there. Essentially, we are talking about rewards, and it's only when we need an incentive outside of normal incentives that we can use rewards in that case. This in turn allows for micro contracts. Imagine if you have to pay a fee every time you run a contract, then you're quickly running out of funds if there's a lot of processing happening, or it becomes really expensive. Without fees, you can just simply say, okay, run this request for me, and quickly calculate it, and it's done. And that allows for very, very granular size of contracts. Another possibility of having it on level 2 is that it is a protocol that uses some mechanisms from the level 1 protocol to be able to do the smart contracting, and you can envision different virtual machines running it. We're currently working ourselves on implementing it using WebAssembly, which uses the WebAssembly virtual machine. But it's very possible to create or use a different virtual machine and have that run in parallel. You can have different protocols, and it's highlighted here already. Whoops. The fact that you can have, that you're not bound when you do it on level 2 because it's simply an application on top of level 1 means that you can create different applications. So if people come up with a better way or a different way or something that matches their use cases better, then they can create their own protocol. Our protocol is simply to show this is how you do it. It's like a reference implementation. And we're using our virtual machine, the WebAssembly virtual machine. We're going to be able to support multiple programming languages for the smart contract that will target those virtual machines. So part of the protocol is that when you start the committee that runs a smart contract, you tell it what the smart contract is, what virtual machine to use, and then it can just go about. And developers can be free once the ecosystem around it grows. They are free to use programming languages that they're already familiar with, and that is a huge bonus. We're probably going to see languages that are not absolutely defined for smart contracts, like Solidity for Ethereum, for example, is a very esoteric language, and it's only usable for smart contracts. But what we're envisioning is a broader way of processing that we want to do. So that's the last point in this slide, the non-financial processing. You could do essentially any processing that you need an audit trail for, even if it does not involve moving tokens. And that's very powerful because that will allow you to create all kinds of interesting applications that are of a neural network style or AI style. But that is more for future. It's just the flexibility is there. We're not closing any doors. Actually, we keep all the doors open as much as possible. And finally, part of the flexibility is that you can adapt the committee size. That means that you just look at the use case and you select the amount of nodes in the committee that you think is necessary to be able to run it correctly and securely. If you have a smart contract that processes large amounts of tokens, then you want the smart contract account to be governed by more nodes than if it's only processing small amounts or no tokens at all. And that choice that you have to determine how big the committee size is for security reasons is very handy. Also, the redundancy aspect. Essentially, with a smart contract, a number of members of the committee needs to agree at some point. A minimum amount of members needs to agree to get to a result. And by having a larger pool to select from, you create redundancy. So if people or nodes would disappear or malfunction or such, then you will be able to filter those out without any problems. Okay, so what do we need as IOTA-based protocol extensions? We are going to be needing three things. One is UTXO accounting, and I'll go into detail in a moment. The other is colored tokens. Again, I will go into more detail about that. And the third is multiple signature schemes. These are the basic elements that we need to be able to actually create a smart contract that is guaranteed to be secure. So, what do we need and why? Oh. Where's my UTXO accounting sheet? I'm sorry, I seem to have misplaced a sheet here and there. Base protocol extension. Oh, I did not. Okay, I'm confusing myself. Sorry about that. Okay. I thought I had subsheets for these, but I didn't. I was going to be drawing, my famous drawing technique. So, UTXO accounting. Why do we need UTXO accounting? Imagine the current situation on IOTA. We have an address A, and that address has a balance of X IOTA. So here is the fun part. That balance has been created. This is how the Tangle currently keeps track of IOTAs in the system. It has a list of addresses, and for each address it has a balance. What happens when a transaction comes in? We have a transaction T1 that says send to address X. Send to address send to address A, send X funds. And then after that transaction, address A contains X funds. In IOTA, we have one-time signatures, which means that we are not reusing addresses. But it is possible to reuse an address, sadly. And that means we have to solve a problem. Because if our smart contract would create a transaction that sends funds to address B, and it sends X funds, let's say it sends them all to address B, then it would generate a transaction T2 that says from A to B send X. So this is our smart contract transaction. This one causes the funds, the tokens from A, the X tokens, to be transferred to B. That's all nice and good, but now imagine that somebody creates a third transaction that sends X or more funds to address A. Now, this empty address contains X funds again, and that means that you could replay this transaction and cause another transfer from A to B. This is something you don't want to do. You want it to be under control of the smart contract. You don't want anybody to simply take a smart contract's transaction and initiate it again and then transfer money again. Well, what do we do to combat this? We can do that by using UTXO accounting. UTXO accounting means that every amount that is being moved to an address not only keeps track of the balance, but also where it came from which transaction it came from. So now we have an address that has X funds that came from transaction 1, and actually you can have more addresses, for example, Y funds that came from transaction N, right? And thus an address can have multiple buckets of tokens, and each bucket is labeled by the transaction that it came from. Now, what happens if I'm going to move the tokens to address B with the smart contract? I will have to specify the bucket that is going to be used. So, move from A to B, what is on X and originated from transaction 1. That means that this is now in B. The smart contracts transaction 2 takes the address A, the funds, the X tokens that were sent by transaction 1 above. Those are being sent to B, and B now has X tokens that have been sent there by transaction 2. That's that transaction from the smart contract. So far, nothing seems different. But if I now have a transaction T3 that will send A tokens or X tokens to A, then I'm not going to be putting it in this same bucket. No, instead, I am going to get my eraser a bit. Instead, I'm going to get X tokens from transaction 3. So this one has been spent. It's no longer an unspent transaction output. That's why it's called UTXO, UTXO, unspent transaction output. So this transaction output has been spent. Now, if transaction 3 sends X to address A, I cannot replay this transaction because this transaction specifically says that it needs to take the X from T1, and there are no X from T1 There is no bucket for that anymore, which means that you cannot replay this transaction anymore. And that in turn means that nobody can interrupt from the outside by sending a transaction that seems to come from the smart contract, because this one is signed. It's signed off to be able to transfer from AX T1. That signature matches that, but there is no signature for a transaction that sends from A to B X tokens from transaction 3. That's a different signature. So nobody can create that except the smart contract who owns the account A. So this is why we need UTXO, to be able to make sure that transactions cannot be replayed. So that is the first thing. Then the next thing that was necessary was, go back, colored tokens. Oh, colored tokens. What the hell are colored tokens? So colored tokens are an extension of the identification. It's like you saw here that if we have it labeled T1, we have a special label, but the moment the tokens are moved to B, it loses its label T1 and instead gets a label T2. Wouldn't it be nice if we could identify those X tokens with a special label that stays the same during transactions? And that is exactly what colored tokens can do. What they do is they add a color label to those same UTXOs. So every single transaction tells what color it is. So I'm sending tokens of a certain color to address A. Now I can move them to address B, and they are still having the same token or the same color C. Let's say that this is C2. I need a different transaction, and when I move this to, I could even move it to address B. I could move to address B and have Y tokens by transaction 4 that have color C2. So now I have in my address multiple originators, multiple unspent transactions. This one actually is now spent by transaction 4 to B, and they have occurred here. And this is by transaction 2. So in an address, you can have multiple buckets, and each bucket has 2 labels. One is the color and one is the transaction it came for. You can even have multiple buckets with the same color from different transactions. They are being kept separate that way, but if you transfer them, you can transfer them as a group with an identical color. So you transfer, for example, 7 tokens from, if we have, let's say we have Z as well, which came from T5, which also has color 2. Then we can send tokens from B to address C. Address C would be by a transaction number 6, and that transaction number 6 sends us, well, let's say X plus Z tokens of color C2. Oh, sorry, Y plus Z. So we have Y tokens of color 2 and Z tokens of color 2, and we can send them at once in a single bucket that comes from transaction 6 and it's the total of those two or a subset of it. It doesn't need to be a complete amount. You can just do the same thing that you do with IOTA, where you have a remainder address, so it keeps going. Remember, this is currently still assuming that we have one-time signatures, so it's still a bit complex, but for now, let's just keep it simple. And so we end up on address C with Y plus Z tokens with color 2, and they originated from transaction 6. So that's the color tokens. And then finally, we have multiple signature schemes. Now it becomes interesting. IOTA has one-time signatures, and that means that an address, after it's being used, should not be used again, because otherwise you open up your signature to being cracked by malicious parties. If you look at Bitcoin and Ethereum and such, an address can be reused, and that has many applications. You can have a fixed donation address, for example. With smart contracts, we also want to have fixed addresses. Why do we want a fixed address? Well, a smart contract is going to govern an address, or it's going to govern tokens. If you would need to keep track of remainder addresses and such, then that means that every node would need access to the seed that can transfer the tokens from that address to be able to calculate the next address and such. But if you know the seed, you are in control of the signature. And this is a problem. That means that any node, so you only need one malicious node, could steal the tokens from that address. And that's something that you definitely don't want. So for that reason, we want two things. One is we need a fixed address. And if we have a fixed address, then we can use what they call BLS signatures. BLS signatures are signatures that are signed by T out of N members. So you select, you define upfront how many members need to take part in the signing process. They each provide a part of the key, and then some party will aggregate all the partial keys into a single signature, and only then you can transfer from the address. This is very powerful. It is actually what allows the quorum consensus in our smart contracts. And because we only have a single address that you need to govern that is associated with that key, you no longer need a seed, so it can be completely secure. Nobody knows the entire private key. Every member in the committee has a part of the private key and can use that to sign it, but the end result they can never create. Only once you have enough parts together, so people have provided you with parts, then you can create a complete signature that's actually able to move the tokens. And that is the final part we needed, because now we have a smart contract address that can be used as a fixed address by other parties to send stuff to, and we can now use that to initiate requests. We simply monitor that address. If a request comes in, then that's where we start processing the request. And then finally, once tokens need to be moved, a BLS signature is being created, and that's being sent to the Tangle for processing, and the Tangle will actually move the funds because the BLS signature is a correct and valid signature. Okay, so those are the protocol thingies we need. Now let's go deeper into the smart contract protocol itself. First, we have what we call our WASP node. To keep in the theme that we are currently experiencing within IOTA, where we have the B node and the Hornet node, we're going to have the WASP node. Actually, this is a clever wordplay on the fact that we are using WebAssembly. WebAssembly is using the WASM virtual machine, and so we are using, we named our node a WASP node to hint towards the WASM, and it's going to be standalone, but I'll go into that in a moment. In this protocol, the node will handle request management. It will need to do committee management. It will need to do smart contract execution management, and it will need to do the smart contract state management. So let's go through each of them. Here you see the wonderful logo that we came up with, or actually Valdas came up with this one. And our WASP node that we envision is for now going to be a minimum viable product, and it's going to be written in Go. We selected Go originally because we had integrated it with the Go Shimmer node, but over the last month, Evaldas has re-evaluated certain things, and we are now literally running a WASP node as a separate node, and it will no longer be completely integrated in the IOTA node, but it only needs a small plugin proxy on Go Shimmer that it can talk to, so that it can keep track of the smart contract messages that are coming in, so it can filter out those messages. And that's all that's needed. And it also will be posting the results to the Go Shimmer node, but everything else, all the processing, is done by separate node software. That means you can run the node on a normal Go Shimmer node, but you can also run it on a separate machine and then simply talk to the Go Shimmer node to run it. So that allows for processing by really small machines, because you don't need to run the entire node with all its database and its large amount of processing that happens when lots of things are happening on the Tangle. Instead, you only do limited stuff on a limited device, and then ask the Go Shimmer node to interact with the Tangle for us. So the WASP node is going to be running the WASM WebAssembly smart contract code. It means that we have smart contract languages that can compile into WebAssembly code. WebAssembly is an interchange format that has been growing interest in, that is actually used normally to be able to compile code and run it in JavaScript in a browser. It's a very compact format, and it allows very fast execution, because it maps literally to native code if necessary. So there's a lot that it can do really fast, it allows you to target different languages that can all generate the same code. So we don't have to come up with a whole new different format or anything, or an interchange format. We're going to go with the standard WebAssembly format. It's very well defined. I'm currently very deep in the WebAssembly code to understand everything that's going on, but the documentation is of stellar quality. The specification is very detailed, and that allows us to go very deep and make sure that we hook all the WebAssembly stuff that we need to the code of the WASP node itself. For now, the initial smart contract language that I have selected is Go itself. So we're going to translate Go into WASM. Then the WASM code will be run on the WASP node and will link to the Go code there. But the execution of WASM is not Go itself. It's a different instruction set, but having Go on both sides allows for simpler interfacing with the inputs and the outputs. You need the Go node, the WASP node itself, at some point needs to pass data to the smart contract code, the state data, and that needs to be processed then, and then needs to be passed back to the Go code as a state update. And having something that already is very similar makes that easier. I am quite sure that once I have done the Go language, there will be quickly a second language just to show how it can be done. And it's probably going to be Java, I think. But anyway, we're going to be able to support all kinds of languages through WASM. And all that needs to be done is to implement the same kind of interface in such a way that the WASM can run on the Go node. So that is the node. What is WASP going to have to do? It's going to handle request management. So it handles everything Tangle related. It does that by talking or listening in actually on the Go Shimmer node, or later if we have different nodes, it could be a Hornet node or whatever. It listens in on the messages and it filters out the smart contract processing requests and also the state updates. The smart contract processing requests are what will actually it's a very well-defined kind of message on the Tangle, and it always involves the account that is associated with the smart contract. Right? Every smart contract has its own address where stuff happens, so it's very easy to filter for it. You just filter for the smart contract address, and everything that has to do with the smart contract address ends up in the WASP node, and then the WASP node will look at that in more detail, see if it's actually a valid formatted request, and if it is and it recognizes the request, it will pass it on to the smart contract. Otherwise it will simply ignore it. One thing that request management also do is enabling the moving of tokens that are controlled by the smart contract. It will handle special events that happen on the Tangle, like snapshots and resyncing. Snapshots will mean that we are losing the audit trails stuff on the Tangle, but every WASP node is going to keep a copy of the audit trail locally in its own database, which means that every smart contract node has its own copy of the entire trail. And that means that it's always reproducible and it's protected with hashes, so nobody can actually fiddle with it or create a false trail or anything. It's always provable correct. Syncing means that what happens when a WASP node, for example, gets out of sync because it was down for a while. Meanwhile, everything went on, and it means that it will need to be able to resync with all the other WASP nodes that run the same smart contracts, and then this is what handles updating Then we have the handling of a few special transactions. One is the special request transaction, that is the Genesis transaction. This is literally the transaction that creates the smart contract out of thin air and initializes it and makes sure that everybody has the same starting state. And after that, you get standard request transactions. And every single one of those, the Genesis and the normal request transactions, result in state update transactions. So every time you get a request, you get a response that is a state update. The state updates are protected with a hash again. State updates are signed by the smart contract. And this is where the BLS signature comes in. The processing happens on all the nodes. Each node signs it with its own partial key, and when we have enough partial keys together, somebody will make sure that the state update transaction is posted, and only then is the state update a fact. Once it appears on the Tangle, everybody can see it, and now everybody knows, okay, our state update is finalized, and then that becomes the new state for the next request transaction. We keep a chain of transactions. Let me go back to my drawing thingy, and let's erase that one. So we have, here we have the Genesis transaction. The Genesis transaction is sent to the Tangle, processed by the WASPs, and it results in what you could say the Genesis state update transaction. Then somebody sends a request X that gets sent to the WASP, and that in turn creates a state update for X. And it references the last one, that last state update we had. So let's see, there's another request coming in, request Y. That one will create a state update for Y. So refers back there, and actually every one will know where it came from as well. So as you can see, this forms a trace, a single trace, and what's important is that, well, for one, we already disabled the ability to replay transactions. So RX, once it has been processed, cannot be processed again, because the WASP nodes already know that they have processed this, and a request to do so again will be failing. But apart from that, you also want state updates to be non-replayable, because otherwise you could kind of fork the traces, and you want a single trace, a single trail. So what do we do to allow this? Well, at the Genesis transaction, we create a smart contract token that is a colored token that is specific for that smart contract. So there's only one colored token for this smart contract. It's actually the transaction hash of the Genesis transaction. That Genesis transaction creates the smart contract token, and it sends it to the smart contract address. And this Genesis token is now forever connected to the smart contract. And with every transaction that happens, with every state update transaction that happens, this one color token is being moved from the smart contract address to the smart contract address itself. But because it is now done by this transaction, it cannot be replayed because it ends up as the Genesis token by the Genesis state update transaction. Then the following state update will again move it, and it ends up as the Genesis color and the state update X. So you create a chain by moving that single token with each update transaction, and thereby you cannot fork it anymore because you cannot link to this one because you cannot move the token. The token has moved away. The token is now here. So this is how we create an audit trail. This single token will stay alive for the entire lifetime of the smart contract. And this is literally following along. We have a similar thing happening here for now. I don't know, Evangelist is currently evaluating whether it's still necessary or not, because we already know on the WASP node which have been processed. But what we could do is we could have the transaction create a special color token with the color of that transaction, and then have the smart contract or the state update transaction then destroy that token. So this token is no longer there, and since only this transaction can create the token, there's only a one-to-one relationship between the request and the state update transactions. So that is essentially how we try to guarantee that everything happens in order and in a controlled way. And we're using the protocol level 1 features to be able to guarantee that this cannot be fucked with. The smart contract token is under control of the protocol level 1, and therefore FPC will make sure that there's only one spend possible at all times. Okay, next, PowerPoint. So that is in a nutshell request management on the Tangle. So then we have another function of the WASP node, which is committee management. For one, the creation of a committee. The smart contract owner decides who will be in the committee and then initiates the creation of a committee. Part of creation of the committee is having the committee, after they have been selected, set up communication and identification between each other, and then they will generate a T out of N BLS key. The owner of the smart contract is the one who determines the T and the N. The T is the amount that need to have consensus, the threshold consensus, out of the N committee members. So that process is happening under wraps, so nobody actually really knows what other, not even the owner of the smart contract knows what the key parts are for each WASP node. And that is what makes this wonderfully secure. Then the committee management, once it starts processing requests, once it starts seeing requests, creating the committee creates an identification, and we can use a hash, which is a random value. And initially we're using the Genesis request hash as the hash to determine an order within the committee members, a random order, but still deterministic. So every WASP node gets the exact same order from that exact same input hash. And uses that to select a leader. That leader is the one that will handle the processing of the next set of requests. It can be one or more requests that are processed all at once, and that is done to limit the overhead on the Tangle. On the Tangle, we only need a trace of request and state updates, and state updates are nothing more than a hash, essentially. So you can have a state update request that processes multiple input requests into a single state update and simply gives you the hashes for each and every one of them. Actually, you only need the final hash, but you can always ask the nodes for the intermediate hashes. Anyway, that makes sure that there is a leader that defines the order in which the requests are going to be processed, and that is done in order of appearance, and everybody can verify that. And then the leader, once the processing has happened, the leader will be the one that processes the rewards, if there are any. And actually, it's the leader that gets the rewards for the current requests. Actually, I'm thinking Evangelist is probably tinkering with that, because it needs to be deterministic for every request who will receive the rewards. Requests will always have a same amount of rewards. And if you have a random leader or a random receiver of the rewards, then you can statistically guarantee that everybody gets their fair share, and you don't have to create large transactions that send to every end members the parts. It also, if you do it that way, that the one that each request has a particular receiver for the rewards, it means that if people don't participate for some reason, they can be left out for that same reason. If as long as you have T out of N that are actually processing, you can actually process the request, and only the leader of that, which can be identified using the signature and by seeing which people have actually signed, you can verify that you can send the reward, etc. There's all kinds of algorithms behind that. Anyway, suffice to say, there's one person or one node that receives the rewards at its reward address, and it's a statistical process, so over time everybody will receive their fair share. The consensus is guaranteed because everybody creates the same processing result in the form of a hash, and the leader, the hashes are signed, so the leader can only guarantee consensus by grouping all the keys together and creating its own state update request or state update transaction, and finalize that with all the partial keys so that it signs it with the complete full PLS key. And that is what guarantees the consensus. So the whole consensus management, consensus guarantee is handled by the committee management. Then we get to execution management, which is on a per node basis, essentially. Here we don't care about committees, about tangles or whatnot. We have a request that came in, and that's being translated into input data to be executed. We figure out what VM we need to use, and we handle the interfacing between WASP and the VM. So the Go code currently of WASP will interface with the VM. It will load the smart contract code into the VM, and it will load the state of the contract into the VM. Then it will execute that request. It will save the new smart contract state internally, so that once the state update transaction comes in, it can actually save this as the final state in the database, so as the new current state. It will handle any runtime errors that occur, especially if you look at creating a smart contract by people who are less capable as programmers. You can have all kinds of runtime errors. We try to be as rigorous as possible in checking stuff, especially with respect to updating the state and trying to move tokens. So errors can show up even after the execution of the request, because the state update contains all kinds of information, and if that information conflicts with what is allowed, even after running the request, a runtime error can occur, and that is something that execution management handles. And if that happens, then it will simply invalidate the request and roll back to the previous state at the entry of the request. And finally, it will create and sign a state update transaction, and that generates the hash and the signature key, and that is what being sent back to the committee management, so that the leader can then see whether everybody agrees and sign the final contract or the final state update. The committee leader, the current leader for the current request, is always running the same thing in himself. So only when everybody else agrees, he can sign the complete state update transaction that he created, and then it can be posted to the Tangle by the request manager. Then finally, we have state management. Every smart contract has a state, and every WASP node keeps track of that state. We start out with a completely blank state. There's nothing there, and the Genesis request is used to initialize that state. It will also register that initial state on the Tangle, so everybody can verify that the code that executed actually resulted in a valid state. Then what it does for every request, if necessary, it could be that the WASP has been down, so potentially or possibly it needs to reload the state from its state database, see if it's up to date, load more state if necessary from other nodes if it can do that, and verify that those states are valid, so it's completely synchronized. Then it loads the current smart contract account state. It needs to know what amount of tokens are there at the moment, so it can verify everything from that viewpoint. It does all kinds of sanity checks after request processing. That's part of what sorry, I'm talking for a long time. I diverted a little bit. I'm almost done, I promise. So the execution manager has done some stuff, and it is part of what the checking does is on the account state whether account transitions are valid, and that's being handled by the state management. The state management is also the one that does the actual rolling back of state changes when errors have occurred. Does the actual calculation of the state hash, because it knows where the state is stored and how to calculate that, and it saves the state to the database. So that's all what it does. Okay, well, that pretty much was what I wanted to talk about. For now, both Evangelist and I agree that we only need a few months to be able to have our first minimum viable product, and our tentative date that we are aiming for at the moment is somewhere August 2020, and please don't start about August 1st or August 30. These projects can take more or less time, but this is our target currently, and I'm very, very hopeful. And given all my experience, I think we'll be able to keep very close to that date to come up with the first MVP. And that brings us to the final part, which is, are there any questions?
Okay, thank you, Eric. Great talk. So we have a few questions here in the chat. Let's go with the first one. It says, what real-life problems IOTA smart contracts are meant to solve? Could you provide some examples?
Well, we're trying to be as general as possible. So we have a few ideas of our own. One that we are using as the MVP smart contract is something that Evaldas already built in the past, but as a hard-coded part of his initial try. And that is what he called Fair Roulette, which is essentially a small betting application that allows you to bet on a color. Nothing to do with color tokens, by the way. It's just you have 10 colors to select from. For example, you bet an amount on a color, and after 20 bets have been placed, the smart contract will verifiably generate a random color out of those 10 colors, and then everybody gets paid out proportionally to what his bet was. It's that simple. And then the new round starts. So that is one thing that we could do. You can go to more complex stuff. I'm sure there will be some IOTA smart kitties or IOTA kitty smart contract that somebody will build. Simpler things, for example, let's say you have an insurance contract on flights, on the whether or not the flight is late. So I take out an insurance contract that will pay me a certain amount of money when the flight is delayed for more than, let's say, 10 minutes, right? Then that smart contract looks at an oracle to get flight status. If the flight status is delayed and is delayed more than 10 minutes, then it will automatically trigger payout to all the people who initiated that insurance. So that would be very simple examples. But there can be way more complex stuff done, and yeah, the sky is the limit, and we're actually looking at the community to come up with all kinds of interesting ideas. Great.
The next one. How can you say about the question made to Nicolas and Federico regarding implementing the smart contracts for their project?
Well, there you go. This is one of those where the community can do anything. If they have a use for smart contracts in their specific application, which I could see, right? Then, yeah, by all means, right? Don't forget we have different things here, right? For one, we have the IOTA streams that they use to handle the payment while charging. You don't need a smart contract at that level. But yeah, I'm sure that at some point we will interface with IOTA streams from smart contracts. And then things can become really interesting, because then things can become automatic. That's the whole idea behind smart contracts. It's completely autonomous, and it's completely secure. Nobody can fiddle with it. And it's well defined what the interface is and what any input, what kind of output it creates. It's all 100% deterministic. Okay, great. Sky's the limit.
Next one. How do you avoid spam smart contracts if they are free?
Well, that depends on the use cases. It could be that requests are only handled if they have been signed with a proper signature, for example. So any other spam request will simply be ignored. And for the rest, it's just the same as spam on the Tangle. It does not influence us unless we need to process something, and we can have all kinds of measures to make sure that we only process in a valid way, and that depends on the use case, right? So we specifically did not preclude smart contracts that anybody can run. Yeah, if we have spam smart contracts, they are still only limited to the nodes that run it. So you get the spam requests, but you can get spam requests on the Tangle anyway, so that's not an issue. And the nodes that run that specific smart contracts, they will decide whether or not they're going to run it. And if they think there's too much happening, they can say, "Fuck this, we won't do it." Sorry, I'm Dutch. To us, fuck this. It's the standard exclamation point.
It's okay. Next one. It says, once IOTA smart contracts are out, what sense does it make to keep using Ethereum smart contracts?
Well, there's certain use cases where Ethereum has a benefit compared to IOTA smart contracts. Security of the smart contract on Ethereum is guaranteed by the entire network of all nodes. Security of the smart contract on IOTA smart contracts is guaranteed by the members of the committee. That means that the security is much higher because it's secured with gigantic processing power and fees and whatnot on Ethereum, which means that if you have an application that needs to process large amounts of money, I would go with Ethereum. I wouldn't. Well, it's possible with IOTA, but you will have to trust the nodes. If there are nodes that are run by a consortium of banks, for example, then yes, you're not afraid that your funds will be stolen. But it's a matter of the trust factor, and you're going to have reputations at some point, and that could also be a smart contract application determining the reputation of a smart contract. Because it's a smart contract, right? The nodes running it, the committee, are associated with that smart contract. So if the smart contract has a good reputation, then by all means use it. Okay,
it's clear. Thank you. Let's move to the next one. How close are you guys from releasing the first IOTA smart contract working version?
Tentative date, August. Evangelist has a first version of the protocol that runs on the Tangle and is now refactoring it into the separate WASP node. Also, he's been refactoring it so that we can process multiple requests in one batch. I'm currently, like I said, I'm in over my head in the WASM code, so that I can correctly determine how to interface the code of the smart contract with the VM, and how to interface the VM with the WASP node in such a way that it's guaranteed to be safe and things like that. And yeah, I'm literally, let's say, about a month away from my first tests, and knowing how this works, those tests will result in refactoring so that it becomes clearer, and at some point those two will meet, right? Evangelist's code and my code will meet in the middle somewhere and have to be tied together. We currently have a verbally defined interface of what it's going to do, and that will turn out in code at some point. And then we need to haggle a bit on, hey, I need this, or hey, I need that, or yeah, but you're supposed to provide this or provide that. And actually, fun fact, Evangelist has been talking to somebody for a little while now, a guy named Diego Esaya, and actually, newsflash, today he actually joined IOTA Foundation and is going to be part of the smart contract team. So yay, we're 3 people.
Great. Yes.
Yeah.
Well, we
But
won't have to wait.
I'm sure that Diego will need to get up to speed a lot. We still need to figure out what exactly he's going to do. Evangelist has been so deep in the whole protocol thing that even me, with the knowledge that I have, will be more of an interference when I work on that same thing, and the other way around as well, right? I have 2 years of experience building virtual machines and such, and interfacing and that. So, yeah, we're trying to stay out of each other's way as much as possible so that we can move forward as fast as possible.
Okay, great. I think Diego is from Argentina too.
Yeah, that is what I was about to say. Diego is actually from Argentina, so there we have our first Argentinian developer.
Yes.
Welcome
so
to the team.
It's no more questions here on the screen.
No, we're done.
So,
Cool.
So great talk, Eric. Thank you for answering all these questions. Your talk has been very clear. So now we are going to say goodbye. Thank you, Eric. Thank you, Nico. Thank you, Fede, who isn't here, but we appreciate your talk and that you are here with us today. Thank you, Carpincho, for your talk, for keeping up this great work in IEN. And let's remember that we are going to have on the 25th our another meetup.
Yeah, it's Friday.
I think Carpincho, this Friday. Okay. It's Spain meetup. So we are going to we hope that we can see you all there too. So without more further ado, I don't know if you guys want to say something.
No, we're fine, I think. I don't know, Nico?
No, just thank you everyone for bearing with us on this virtual meetup. And I hope you are still eager to learn more about IOTA and everything we've talked about.
Okay, great.
Okay.
So stay safe, guys, and thanks a lot for being here today.
Okay, bye. Thank
us.
you.
Thanks.
Bye, everyone.
Bye-bye.
Bye.